Hello ladies and gents, this is Daniel for Rock the JVM, and in this video I'm going to share 8 Scala pattern matching tricks that you might just not know. So this video is for the people who are either getting started with Scala or for the people that already have some experience with Scala but are using pattern matching only in its basic form, either to deconstruct case classes or as a switch on steroids. So the recommendations that I would have for this video is either to write code alongside me so that you can remember these tricks that I'm going to share, or when you need more elaborate pattern matching in your day-to-day or at your job or in your project, just to return to this video. You can also find a written version of this video at rockthejvm.com/blog. Alright, so here I am in my development environment where I created an object that I'm going to add a main method to so that we can test the various things that I want to show you. So I'm going to add a main method here in IntelliJ. I'm an IntelliJ IDEA. If you have a Scala development environment, you would probably do that as well. Now, if you're like most Scala programmers, you're using pattern matching in one of two ways. To either use that as a switch on steroids, meaning that if you have a number, say 44, you would do something like this. I would define, let's say, ordinal as a number, match, and you would put in a number of cases here with constants, like case 1, and you would return first, case 2, you would return second, case 3, you would return third, and for anything else, like a default case, you would return a number plus th, or something like that, all right? So in the case of 44, you would return 44th. So this is the switch on steroids kind of pattern matching that is very widely used. The second case is the deconstruction of case classes. So if I had a case class, let's say person, with, let's just say, a name as a string and an age as an int, you would be able to deconstruct instances of these case classes. So let me define a val called Bob. Let's say person with the name Bob and age 34. Well, if you want to deconstruct this case class, you would simply say something like this. Let's call this Bob greeting. As Bob match, and you would say case, and then you would say person with a name and an age, and you would return some kind of string like hi, my name is, and I would inject the name, and I am a years old. This is something like a kid would say. Hi, my name is Daniel and I am whatever years old. So if you're a Scala programmer, I'm pretty sure you are familiar with these two use cases. Now, the purpose of this video is to show you some more tricks that you're probably not aware of or you may not have used yet. The first trick that I want to show you is the list extractors. So let me create a list. Let's call this numbers list. As a list with 1, 2, 3, and 42, something like that. Okay, now for lists, we have dedicated patterns that I'm going to show you right now. So let's say we want a pattern that checks a list, and the list must have the third element equal to 3. And if the list has the third element equal to 3, we will extract the fourth element and then we will do something with it. So let's call this must have 3 as numbers list match, and I would use the following pattern. I would say case list, much like we use a pattern matching for case classes, and then I would start putting micro patterns for every element in the list. For example, I don't care about the first two elements, so I would put in underscores. The third element would be 3, and the fourth element would be something else. And then I would do something with that something else. So the list has third element 3, so the fourth element is, and then I would put in something else. So notice that in this case, the list pattern also looks very similar to the one that we used for case classes. But in this case, you can put an arbitrary amount of members here up to 22 because the list unapply method has 22 max arguments, and then you can put in micro patterns for every single element of the list. So this is pretty powerful. That was trick number 1. Trick number 2 is also related to lists, and this is Haskell-like prepending. If you know Haskell, it has this pattern matching for head, colon, tail kind of pattern matching. Let me show you. So let's say starts with 1 as numbers list, match, and I would say case, and watch what I'm writing. I'm going to say 1 colon colon tail, and I would return list starts with 1. And this tail that I've written over here is a variable pattern, much like we used something else here. So you can use the tail in the returned expression. So something like that. Now, this pattern is very useful because when you define an API method like process, and you receive a list as a list of int, for example, you would want to say a list match, and then you would put in cases for when the list is empty and for when the list is not empty. So you can say a list match case nil, and you would return list is empty. And in case it contains head, colon, tail, you would process the head and the tail. So list starts with, and then you would inject head, tail is tail. Or you would do some kind of recursive processing for the tail if you wanted. So this is pretty useful. Let me show you another trick. Let's call this trick number 3, the var arg pattern. Again, this is useful for lists. So I'm going to say, let's call this don't care about the rest. For reasons that I'm going to show shortly, I'm going to say numbers, or numbers list, match, and I'm going to use the following pattern. I'm going to say case, and I'm going to use the list with underscore 2, and watch what I'm writing, underscore star, meaning the rest of the elements. And then I'm going to return a string like I only care about the second number being 2. This particular pattern with the underscore star, this is the variable argument pattern in which you can test the first couple of elements or the first few elements, and then the list might contain some additional elements that you don't care about. So this is how you would do something like that, because you otherwise will not be able to test the second element being 2 with just the pattern list with underscore 2 and just like that, because that will assume that the length of the list in question is equal to 2, whereas this particular pattern can match lists of arbitrary length. So I hope this makes sense. Let me show you another one. Trick number 4. Other infix patterns. We call these infix because the pattern name itself is in between the elements being matched. So if you take a look at this particular pattern with 1 colon colon tail, the colon colon is the name of the pattern, but it sits in between 1, which needs to be matched, and tail, which needs to be matched. This is the same as if I wrote colon colon with 1 and something else. But because Scala syntax is so permissive, the colon colon can sit in between 1 and tail. So I can say 1 colon colon tail, which would be the same. It's also much more human readable, much more mathematically readable. So this is why these patterns are called infix. Now I'm going to show you some other infix patterns, because in the previous tricks we had some tools about how to test some elements of the list, and in particular testing the head of a list is very straightforward and very easy. But what do you do when you want to test the last element of the list? And this is what I'm going to show you right now. So I'm going to say val, let's call this must end with the meaning of life, because our list is ending with 42. I'm going to say numbers list match, and I'm going to write this as follows. I'm going to say case a list with, let's say, 1, 2, and something else. And watch what I'm writing now. I'm going to say colon plus 42. And I'm going to say that's right. I have a meaning. So this pattern is able to test that 42 sits at the end of a list. And this is an infix pattern because the operator itself is infix. It sits between the first element, which is list 12 underscore, and the second member, which is 42, in much the same style as the colon operator earlier. This is why it's called infix. Now, this particular pattern is very useful because it allows you to test the end of a list, and combined with the underscore star pattern, with the varg pattern, you would end up with a very powerful one. You can say, let's call this val must end with the meaning of life. Let's call this 2 as numbers list match. And I would use the following. I could say case list with 1 and underscore star colon plus 42. And you would say, I don't care how long the list is. I just want it to end in 42. So this particular pattern combination with the varg pattern and the infix pattern with append is very powerful because it allows you to test lists of arbitrary length, only that they end up with 42. Alright, so I hope this was useful. Let me show you some tricks that are not necessarily related to lists. So I'm going to say trick number 5. This will be type specifiers, which you might have seen before. So sometimes we really don't care about the values being matched, but only their type. Let me show you an example. So let me say I have an API call. Let's call this give me a value, which returns the type any. And let's say it returns, I don't know, the number 45. But you don't care about the value, you only care about the type. And you want to match the number being returned or the value being returned against its type so that you can return something else depending on it. So I'm gonna define a val, let's call this give me the type, as give me a value, match, and I'm gonna say case underscore colon string, just to test if the value being matched is of type string. So let's say I have a string. In case I get an int, I will return I have an int. In case I get something else, let me put in an underscore, I got something else. So the colon type here is the fundamental aspect of this trick. It allows a value to be matched against its type. These are also called type guards. The drawback with the type guards and the drawback with type-related testing is that this pattern matching is based on reflection, so beware of performance hits if you are using this all the time. Let me show you trick number 6. Trick number 6 is name binding. This might prove useful in practice because I've seen the following case over and over and over again in Scala code. So let me wrap some scenario here. So let's say we have an API call for request more info, which receives an argument in the form of a person, the kind of case class that we defined earlier. And this will return a string. Let's say the person, and I would inject p.name is a good person, or something like that, okay? So you have an API call, which given an argument of type person returns something else. And I have just mocked the implementation over here. And let's say we have our very old Bob with Bob and 34, and I want to match Bob with the following implementation. So I'm going to say val, let's call this Bob's info, as Bob match. And I'm going to match Bob against its case class. I'm going to say person with name and age. And then I would return the following string. I would say name info, so Bob's info in this case, name's info. And then I would call the request more info, API call. So I would inject the following request more info, but I would need the instance of person being matched. So I would use either Bob, or if you don't have the type of the Bob, if you're matching the any case, they would reconstruct the person with a name and an age. So notice how we have a new useless instance of class person when Bob would suffice. But when the type of Bob is not person, for example, when it's a superclass of person, this trick would be the only way to go. I've also seen people converting Bob to person, like using as instance of, which is also pretty terrible in code. So let's save Bob by putting a name in front of it. So you can save parts of a pattern by putting names in front of it. For example, p at. So when you say p at and then you follow with a pattern, then that pattern is bound to the name p, which is something that you can use later. So I can put in p there. You can also use name binding inside the pattern for when you want to match parts of a pattern. So for example, if we wanted to use the age here, if the age was of a type that was more complex, like a social security number that contained Bob's age or something like that, you would use a name at, and then you would use the rest of the pattern. For example, I use a at whatever. Okay, now a at whatever is pretty useless. I can simply use a, but you get the picture. You can use the name binding with the name at a part of a pattern inside another pattern. So this is also pretty powerful, and I hope you find it useful. Let me show you trick number 7. Trick number 7 is conditional clauses. We call them guards. You might have seen these before. So if you're like me, you probably tried at least once to pattern match something that satisfies a condition, not necessarily matches a value exactly. And because you only knew the anything, that is the underscore, and the constant, that is the variable name, patterns, you gave up pattern matching and used chained if-else's instead. So let me show you another way. So let me create another more elaborate version of this ordinal string here in the following way. Let's call this ordinal 2.0. Let's call this 2. I'm going to say a number, match, and I would copy the first 3 cases because I don't want to type them all over again. Now, if you want to be correctly English, like say 21st or 22nd instead of 22th, like I used here in the ordinal, you would use something like this. Case n, if n mod 10 is equal to 1, you would say a number or n plus st. And then I would put in some cases there. If n mod 10 is equal to, I would return n plus nd. Case n, if n mod 10 is equal to 3, I would return n plus rd. And then if I get something else, I would simply say n plus, or a number plus the th suffix. So this is a powerful way to combine exact matching cases with non-exact matching cases, with cases which only match a condition rather than a well-defined value. So this is trick number 7. Trick number 8 is alternative patterns. This is for the situations where you return the same expression for multiple patterns because you don't need to copy and paste the same code. So let's say I want this list, 1, 2, 3, 42, to either have the first element 1 or the third element 3. If that is the case, then I like this list. So let's create a value. Let's call this my optimal list as numbers list, match, and I would put in the following 2 conditions. In the case that the list has 1 and whatever else, I would return the string, I like this list. Also, if the third element is 3, I would copy this, and I would say underscore, underscore 3, and then the varg pattern, and I would still return I like this list. And in case I get something else, I would return I hate this list. So as you see here, I have 2 different cases with the exact same result. And very often when this happens, you would copy and paste these cases because they're often very similar. There's an alternative way to do that. Instead of copying and pasting cases, you would say case list with 1 and underscore star, or list with underscore underscore 3 and underscore star. So you would alternate the patterns, either this pattern or this pattern, with the bar operator. So the bar operator has the purpose of chaining these patterns as an alternative for this expression being returned, so that you don't copy and paste these patterns over and over again. And in this main method, you can go ahead and play with these values that I show over here. So you can, for example, print line my optimal list. And if I go ahead and run this, if I gave a second or two for the compiler to start and run my code, then I would say I like this list because the pattern was matched. All right, so I hope this was useful. I'm Daniel, and you can find this article at rockthejvm.com/blog in written form, and you can follow me on Twitter and LinkedIn with the links in the description attached to this video. Now, I'm dying for feedback, so please leave yours in the comments, and if you like this video, go ahead and subscribe, because more videos like this will be coming soon. Until next time, thank you for watching.